Hi, I'm Pat Kelly. Okay, in this problem, they give us another data set. They're asking us for the standard deviation, but they do have a request for us that we use the alternative formula for standard deviation, which is generally a little smoother going with the computation, so it's a good thing. You definitely want to get used to using it. I'll show you how in this problem. Now, if we're going to find standard deviation, no matter which way we do it, you always need the mean. So start with that, as we do want to calculate our x bar. Our x bar, you know how to calculate. We're going to add these numbers and then divide by 5, because there's 5 numbers. I'm going to grab my calculator. Don't be ashamed to grab yours either, because these are some pretty big numbers. Okay. All right, and then I'll just add those numbers: 246, 336, 473, 167, 219, just so that we're on the same page. I'm getting 1,441 after adding, but then divide by 5. And for my mean, I'm getting 288.2. You agree? Okay, now moving on to our standard deviation using that alternative formula. Come over here. Sigma equals. Now this is a square root, and the expression on the inside is somewhat sizable, so let me just get started with my radical, but I've got quite a bit to fill in. Okay. The first thing you're going to fill in is actually a fraction. I'm talking slowly just so that you'll know how to set yours up as well when you're on your own. So in this fraction then, you go to each data point one at a time and square it. So 246, but I'm going to need to square it. And then add and go to your next data point, 336 squared, plus 473 squared, plus 167, is that where I'm at? Squared, plus the 219 squared. Okay, that's all in the numerator of this fraction. In the denominator is just that number of data points again. So that's our 5, just like we divided by 5 up with our mean. Okay, and I'm not even ready to close off the radical hat yet, because there's more with this formula. You also have the subtraction. After the fraction, you subtract that mean, but squared. So 288.2, but squared. Especially because of that decimal. I think I'll throw parentheses around that so you can see the exponent. But that's my formula. Okay, let me try to close my radical hat. All of this under that square root. And if you've noticed, I've been clutching my calculator. I'm not doing this by hand. Okay. But I am going to take one in-between step here, just so we can make sure we're getting the same numbers. So in this step, let me just calculate the numerator. We'll see if we agree with our numbers. And while I'm at it, I think I'll do the 288.2 squared as well. Okay. But first, the numerator, 246 squared. I'm adding in between, plus 336 squared, plus 473 squared. 167 squared plus 219 squared. I think I have all those added. So I still have my square root. I still have my fraction. But my numerator is looking like 472,991. You still have your divided by 5 minus. And I also wanted to do the 288.2 squared in this step. My result is 83059.24. I'm just doing this in-between step to see if we can agree with those numbers. You with your calculator, me with mine. Okay. All right. If we check each other and we're good, let's move on and finish this problem actually. I am going to switch to a approximately equal to. But let's do this calculation, and I think I can do it all at once with a square root and then 472,991. But divide that by 5, subtract 83059.24. Close up my square root operation, hit enter, and I'm looking at a 107.42 with rounding. Okay. All right, that's my answer for standard deviation. And I know these are big numbers. You want to have a calculator handy, but still the calculation's a little bit smoother than with the original formula. So get the hang of this one by going and practice some more on your own. All right.